All right, let's continue with the homework from class here. So the last one of this, trying to find all the real zeros. And this one is going to be, of course, the strange one. It's not going to work as we thought it's going to work here. So let's go for it here. Let's at least try first the P over Q and see what comes of it here. So P, that is all the different factors of 9. It's this little 9 right here on this corner right there. Here, 9. So I can get a 9 by 9 and 1 and 3 and 3. So all the different factors of 9. Okay, then we have the Q. Q is all the different factors of 1. It's the number in front of x squared, the coefficient, so plus or minus 1. And then what we do is we put them as ratios. Since Q is just a 1, that means everything else stays the same for P. So P over Q is just 1 over 1, 1 over 3. I'm sorry, 1, 3, and 9. Okay, so first things first, when we do synthetic division, remember that all the different exponents have to be represented, right? So this is the number in front of x to the 4th. There's no x cubed, so we've got to put a 0. X squared has a 10 in front of it. X to the 1 power it's not theirs. And then we have a 9 as a constant term. So also notice all of these are positive numbers. So if they're all positive numbers, there's no way you can add numbers together and multiply and still get a 0 at the end. So you're going to have to try the negatives. And as you try them, here's our little problem, is that none of them work. Let's say I try -3. So as I go down 1, 1 times -3 is -3. 0 plus -3 is -3. -3 times -3 is 9. And then we're at 19 already here. There's no way this guy's going to give you a 0. So I tried -1, I tried -9, and none of them work. So we're stuck. So now the question is there any other possibility? So this is, of course, this is the last one. This is the tricky one of the trade here. So ask yourself, okay, hold on. Notice there's 3 terms here. There's an x to the 4th, right? And there's a 10x squared, and then there's a 9. So let's see if we can factor this down. So I'm going to try to factor this. So if I do that, I'm going to set it equal to 0, since I'm trying to find zeros anyways. And the question is, what numbers can I multiply to give me a x to the 4th? Well, that'll be x squared and x squared, right? That'll give me x to the 4th. So now the question is, what numbers multiply give me a 9, but add to give me a 10? So multiply to 9, add to 10. Oh, that's easy. That's just 9 and 1. So notice we did this by factoring. We didn't have to do P over Q, but it's only very specific. It's specific because we were able to factor the integers themselves. The P over Q is made to be a generic system that works all the time. And this is the one case it doesn't work. So let's set each of these guys equal to 0. And then we're going to subtract 9 from both sides over here. We're going to take the square root plus or minus, and we got ourselves a, let's see, plus or minus. 9 becomes a 3, but there's a negative inside there, so how about 3i? Same thing over here. Subtract 1 to go to the side. Take the square root of both sides, plus or minus, and the definition of I is actually it's the square root of -1, so we get ourselves x is equal to plus or minus 1. All right, so there's our 4 answers. Positive 3i, negative 3i, positive I, negative I would work for those. Awesome, done. There it is. Next problem. All right, this one, 123. -2, okay. So a degree 3 polynomial function f has real zeros of -2, 1/2, and 3. And its leading coefficient is negative. So somehow we've got to stick a negative inside there at the end. So first of all, we're going to write the equation. Okay, we're going to sketch the graph about how many different polynomial functions are possible for f. Okay, so how many different polynomial functions are possible for f, given the fact that it has to have a negative leading coefficient and it has to have these particular zeros in place. All right, let's try. So first things first, let's start building out. We have to write out an equation for f. That's what we want to do. So if -2 is a 0 or a root, we're going to say x equals -2. Since 1/2 is also an answer, we got x equals 1/2, and we got x is equal to 3. So here's what we're going to do. We're going to have to build out this polynomial. So we're going to add 2 to both sides, and we're going to get ourselves an x plus 2 is equal to 1. You're going to see that this is the exact opposite of a factoring process. That's what we do here. So how about this? We're going to multiply both sides by 2. 2x is equal to 1, and we're going to subtract 1 from both sides and give me 2x minus 1 equals 0. And the last one here, so subtract 3 from both sides, and I got myself x minus 3 equals 0. So how do we make this into a polynomial? This is a third-degree polynomial, so we actually have 3 answers, so we're perfect. So here's what we're going to do. We're going to multiply. So notice real quick here, before I even do this, I'm going to go back. Notice that 2x plus 2 is the exact same thing as 0. That's what equal sign means. X plus 2 is the exact same thing as 0. 2x minus 1 is the exact same thing as 0. X minus 3 is the exact same thing as 0. So the question is, what is 0 times 0 times 0? Still be 0, right? So how about this? X plus 2, 2x minus 1, x minus 3. All that, because they're all 3 zeros anyways, we can just say they're equal to 0. All right, then we have to multiply this out. So I'm going to just multiply the first 2 parentheses together. So x times 2x makes 2x squared, right there. X times a negative 1 makes negative x. 2 times 2 is 4, so 4x. And 2 times negative 1 is negative 2. There it is. I'm running out of room here. So let me copy this over to the next slide. And we'll start simplifying it here. So let me copy this over. And let's simplify. So 2x squared stays, but a negative x and 4x makes 3x minus 2. All right, everything else remains the same. And we are going to multiply again. So there it is. 2x squared times another x makes 2x cubed. That should make a negative 6x squared. Now we multiply the 3x times everything in the other parenthesis here. 3x times x is plus 3x squared. And a minus 9x. And then multiply negative 2 times everything here. So negative 2 times x is negative 2x. And then negative 2 times 3 is a positive 6. Voila. Simplifying this down, I think we have our polynomial here. So how about 2x cubed? Negative 6 and 3 make negative 3x squared. Negative 9 and negative 2 make negative 11x plus 3. And voila, there's our polynomial. Oh, we forgot something. It says that the leading term has to be a negative. So that 2 can't be a 2. It could be a negative 2, that's fine, but it has to be some kind of negative number. So all we got to do to make it a negative, we're just going to multiply it by negative 1. So change all the signs here. Oh, and done. I should make it equal to 0, yeah. Right there, equals to 0. All right, so now the question, I'm done right here. So notice this is one unique polynomial. But the question is this. Do I have to multiply negative 1? Can I multiply by negative 2, negative 3, negative 4, negative 5? If I multiply by that, will that change my x-intercepts? Now, we'll talk about it in just a second here, but yes, you can multiply this by a negative 2 instead of a negative 1. And if that's the case, this will just be a negative 4x cubed plus 6x squared plus 22x minus 12. Okay, equals 0. And so what happens here is that is also a polynomial that works. So let me explain here why that's going to happen here. So let me just do a generic little thing here. So let me get a polynomial that has 3 x-intercepts. So if I have a polynomial that does that, let's say I have a graph that looks like this. Again, not related to the problem itself. I'm just doing a generic little problem. If I were to do a vertical stretch on this, do my x-intercepts change? No, they don't. The x-intercepts remain exactly the same spot. The only thing that changes is the height of this guy, right? But notice the x-intercepts did not change. So here it is, vertical stretch. That's what we'll be doing. We're multiplying by negative 1, by negative 2, by negative 3, by negative 4. Does not change the x-intercepts. So how many answers are possible? There's an infinite amount of answers that are possible. You can have an infinite amount of polynomials, all different. They're just multipliers of each other, and they will all have solutions of -2, 1/2, and 3. All right, and this one looks like we're going to graph this guy. So this is now 2.6, 2.639. Okay, let's go for it here. So question is, can we write this in the simplified form? Simple form. Yeah, first things first over here. I think I can factor this down. So try your hand in factoring this down. Thinking to myself, let's see what ways I can get a 2x squared. That's going to be a 2x times x. What ways can I get a -3 so that the middle becomes a -5? So -3 at the end. It'll have to be 3 and 1. So now the question is, how do we position the -3, or one of them's the negative here? So how about this? This will produce a -6x for me. So if I put a +1, I think that will do it. -6x plus 1 makes -5x, and a +1 and a -3 make -3. Perfect. And that was the easy factoring. This one, do you guys remember way back, like what, the first week of class or second week of class, we had to do something called the grouping method. That's what this is. Notice there's 4 terms. What we're going to do is we're going to put them into 2 different parentheses with a plus sign between the 2 parentheses. So we're going to stuff that -x plus 2 into the second parenthesis. So this is called the grouping method of factoring. Grouping method of factoring. All right, let's see what gets to go out of the first parenthesis would be an x squared. Left would be x minus 2. What gets out of the second term is a negative in order to make, or -1, in order to make the second parenthesis exactly the same as the first one. Perfect. So then we're going to factor out the parentheses that's the same as in front, right there. So we're going to take out the x minus 2s. The leftovers now are x squared minus 1. But does that factor? It sure does. That does factor into a x plus 1, x minus 1. So now x minus 2, x plus 1, x minus 1. Perfecto. We're going to put that all underneath here. Okay, this one's a toughie. This is, again, a second to last of the factoring or the graphing ones here. Okay. Let's see. Next is the y-intercept. Y-intercept, we go back to the original problem itself. Now we plug in zeros. And as you plug in zeros, only the in numbers will be relevant. So get -3/2 or -1.5. The x-intercept, we're going to take our numerator, stuff in the numerator, we're going to set those guys equal to 0. And so with a little bit of work, if you set 2x plus 1 is equal to 0, you're going to get yourself an x equals -1/2. If you set x minus 3 equal to 0, you're going to get yourself a 3. So we got 2 x-intercepts and a y-intercept. So I have 3 points along this guy. All right, not done yet. We have vertical isotopes to do and horizontal isotopes. Number 4, vertical isotopes. So here is where the denominator is set equal to 0. And if you set the denominator, each of the denominator pieces equal to 0, we're going to have ourselves vertical isotopes at 2, 1, and -1. All right, horizontal isotopes then. Slant isotopes we did not cover, right? But horizontal isotopes, if we take a look at just the numbers in front, that's all we care about for horizontal isotopes. And we say to ourselves, look, on top we have a degree 2. That's the exponent that's here. And on the bottom, we have a degree 3. That's the exponent that's here. So notice this is a proper fraction. If it's a proper fraction, if the top is smaller than the bottom, that means we do have, there it is, degree 2 is less than degree 3. That means we do have horizontal isotopes, and it is y is equal to 0. Okay, based upon that information, can you now graph this guy? So let's put in everything we know. So make a graph, make a few little tick marks here, my scales. And we go with it here. So let's see, I have a vertical asymptote at -1. positive 1, and 2. Okay, this is a little bit of a toughie as we think about this here. So y-intercept, a horizontal asymptote, is y equals 0, and my x-intercepts, let's see, it was at negative 1/2, and it was also at 3. Okay, based upon that information, can now we graph this guy? Oh, and then also don't forget, we have split direction, right? If you go back to the simplified form, all of them have degree 1 next to them. See if I can go back right here. Notice on x minus 2, there's a 1 power. X plus 1 is a 1 power and a 1 power. So that means they're going to be all split directions. Okay, so let's go. I guess the best way to graph is right here. Notice you have an x-intercept and a y-intercept. The only way this can happen is if it started high and it went through both of those points and it kept on going low. Okay, since all of these guys are split direction, and on the left side we don't have any x-intercepts, here's what we're gonna do. It has to be split direction, so it has to start on the bottom. That means it goes out like this. Oh, the tricky one is this one here. It's a split direction here, but then there are no x-intercepts. So this guy's gonna go like this. It's gonna go start up high, and it's just gonna turn around and go back up. The reason is because there's no x-intercepts to do. Okay, so then we have split direction at 3 as well. So split direction, this one does have an x-intercept. So the way this works is you come up, you go hit the x-intercept, you cross it, and then you kind of flow back down to the y equals 0 horizontal asymptote. That is it. There's the graph of this guy. That's a toughie. All right, next. And the last one here. So t squared minus 1, t plus 1. We're going to graph this guy. Let's go with it here. First things first, can I simplify it? So on top, I think this simplifies the next t plus 1, t minus 1. Oh, t plus 1s are gone. This is interesting. Look at this, guys. This all cancels, and we're just left with t minus 1. Now, hopefully the variable doesn't confuse you, right? This is the same thing as like if we did x, right? This would be x minus 1 as our graph. This would be like mx plus b. That's what that looks like. Except the variable has been changed. That's it. So this will be a line. We know how to graph these guys. We know how to graph lines. Okay, but let's just go through because this is because of the because the cancellation of t plus 1. I'm going to look at it here. So number 1. Number 2, any y-intercepts. Yes, plug in zeros in here. Original problem, t becomes 0 everywhere. So negative 1 over 1 makes negative 1 as a intercept. And any x-intercepts. Yeah, we're going to set the top. Now this is the numerator, but right, because this is all over 1, right? We don't have a denominator now. So t minus 1 is the numerator. So we have ourselves 1. So y-intercept negative 1, x-intercept 1. Keep on going. Vertical asymptotes. Are there any? No, there are no vertical asymptotes because the t plus 1's canceled on us. Now we do have something here. Let's see. At t is equal to negative 1, right? That's the one we canceled. We have ourselves an open dot. Okay, and then horizontal asymptotes, slant asymptotes, which we did not cover here. What we do is we look at the degree. Degree on top is 2. Degree on the bottom is 1. Oh, this is an improper fraction. Since there's an improper fraction and the degree on top is higher than the degree in the bottom, there is no HA, no horizontal asymptotes whatsoever. All right, with that said, we're going to graph this guy. But we should know how to graph this. We should know how to graph x minus 1. It's just The variable has been changed. That's it. So no HA. So I'm graphing t minus 1. Here it is. It is just a line. It's a line that has a y-intercept of -1, has x-intercept of 1. It comes through. Now, the careful thing is, notice we have an open dot at -1, right? So we can graph this here, down arrow, coming back up. And right at -1, I'm going to break my graph, and I'm going to keep on going. And I'm going to put an open dot right there. All right, that is it right there. That is end of that one. So as a conclusion here, this is a straight line. This is a very different than what we're used to with the vertical isotopes splitting. This just becomes straight line with a little exclusion, one exclusion at t equals -1. All right. Well, I wish you well on the test as you guys are doing it today, and enjoy your break.